Most people think of concrete as a solid, immovable rock. But on a microscopic level, concrete is alive. It breathes, it expands, and it contracts. In regions where the temperature drops below freezing, concrete without the proper air content is a ticking time bomb. When water enters the pores of the concrete and freezes, it expands by about 9%. Without entrained air, billions of microscopic bubbles. That expansion creates internal pressure that shatters the concrete from the inside out. This is why the ASTM C231 pressure method is the most critical test you will perform on site. Today we are going deep. We aren't just showing you which buttons to press. We are mastering the Gilson concrete pressure meter, Type B, with the Gorilla Gauge. This is the tool that stands between a project that lasts 50 years and a project that fails in 5. Before we get our hands dirty, let's talk about the engineering. The Type B meter operates on Boyle's law. By applying a known pressure to a known volume of concrete, we can calculate the air content based on how much the volume of the air inside the concrete compresses. 1. The base, the measuring bowl. The Gilson base is a 1/4 cubic foot vessel. It's made of cast aluminum, which is lightweight but rigid enough to maintain its volume under pressure. This is vital. If the base flexed, your reading would be useless. 2. The cover assembly. This is the brain of the unit. It contains the air chamber, the valves, and the Gorilla Gauge. Notice the 4 heavy-duty clamps. These are designed to provide a uniform seal across the entire circumference of the flange. 3. The Gorilla Gauge. Standard gauges are the weakest link in air testing. They are fragile. The Gorilla Gauge included in this Gilson kit is a different beast. It features a high-impact, shock-resistant housing and a precision movement that is specifically calibrated for the pressures used in ASTM C231. 4. The petcocks. You have 2 of them. These are used to bleed air and inject water. In the Gilson model, these are stainless steel to resist the corrosive nature of the lime and concrete. You cannot get a good test from a bad sample. Step 1. Sampling. Ensure your sample is representative of the entire load. According to ASTM C172, you should take samples from the middle portion of the batch. Never test the very first or very last bit of concrete coming out of the truck. Step 2. The equipment check. Before the truck arrives, verify your kit. Is the gasket clean? Is the tamping rod straight? Do you have your mallet? If the concrete is already there, and you realize your syringe is missing, you're already behind. Step 3. Wetting the base. Dampen the interior of the measuring bowl. You don't want a pool of water at the bottom, but a moist surface prevents the dry metal from wicking moisture out of your concrete sample, which could alter the slump in air results. Layer 1. The foundation. Fill the bowl to 1/3 of its volume. This is approximately 3 inches deep. Rodding. Use the 5/8 inch tamping rod. You must rod this layer 25 times. The strokes should be distributed evenly. The mallet. This is where many technicians fail. After rodding, you must tap the sides of the bowl smartly 10 to 15 times with the rubber mallet. This isn't just a suggestion. It's a requirement to close the voids left by the rod. Layer 2. The middle. Add concrete until the bowl is 2/3 full. Rodding. Another 25 strokes. Crucial tip. The rod should penetrate the first layer by about 1 inch. This knits the layers together, ensuring there isn't a seam of trapped air between the lifts. The mallet. Tap 10 to 15 times. You should see bubbles rising to the surface and popping. That is the accidental air leaving the sample. Layer 3. The finish. Overfill the bowl slightly. Rodding. The final 25 strokes. Again, penetrate the second layer by 1 inch. Strike off. This is an art form. Using the strike-off bar, saw it across the top. The goal is a surface that is glass smooth and exactly level with the rim. If you have a small void, take a tiny pinch of the mortar, not the large rocks, and fill it. Sealing the unit. Wipe the flange clean. Any grit will cause a pressure leak. Place the cover on and clamp it down in a cross pattern, like lug nuts on a tire, to ensure even pressure on the gasket. 1. Water injection. Close the air bleeder valve on the air chamber. Open both petcocks. Use the syringe to inject water into one petcock until it flows out of the other without any bubbles. This ensures the space between the lid and the concrete is entirely occupied by an incompressible fluid, water, so that the only thing compressing is the air inside the concrete. 2. Pressurizing the chamber. Pump the air until the needle on the Gorilla Gauge passes the initial pressure line. Pro tip: overpump by about 0.2% or 0.3%. Then use the bleeder valve to slowly bring the needle back down exactly to the line. Give the gauge a light tap. The needle should be rock steady. 3. Releasing the pressure. Open the main air valve by pressing down the lever. Hold it for a few seconds. While the lever is down, tap the sides of the bowl again with the mallet. This helps the air pockets stabilize under the new pressure. 4. Reading the gauge. Read the dial to the nearest 0.1%. This is your apparent air content. Here is the part where many people get confused. The gauge doesn't know what kind of rock is in your concrete. Some aggregates, like slag or certain limestones, are porous. They have air inside the stones. A equals A1 minus G, A equals final air content, A1 equals apparent air content, what the gauge says. G equals aggregate correction factor. If your gauge says 6% and your aggregate correction factor is 0.4%, your actual air content is 5.6%. If you don't account for this, you might be rejecting perfectly good concrete or, worse, accepting concrete that doesn't have enough entrained air to survive a winter. A tool is only as good as its calibration. ARS TMC 231 requires regular calibration. The Gilson kit comes with a calibration cylinder. To check your meter, fill the base with water. Follow the same pressurizing steps. The gauge should read 0% because water does not compress. If it doesn't read 0, you need to adjust the initial pressure line. One of the best features of the Gorilla Gauge is the external adjustment screw. If your gauge is slightly off, you don't have to send it back to the factory. You can recalibrate it in the field using the instructions provided by certified MTP. If you release the air and the needle doesn't move, or if you hear a hissing sound, you have a leak. Check 1. The gasket, is it cracked? Check 2. The petcocks. Is there dried concrete in the seat? Check 3. The clamps. Are they tight enough? At the end of the day, do not just rinse the bowl. Remove the petcock stems and flush them with water. Use a small brush to clean the underside of the lid. Concrete is a chemical. It will eat away at the aluminum and the seals if left overnight. Precision in testing leads to excellence in construction. Using the Gilson concrete air meter with the Gorilla Gauge gives you the confidence that your data is accurate, your project is safe, and your reputation is intact. Whether you are working on a small residential driveway or a massive bridge deck, the standards remain the same. Accuracy matters. For more technical guides, replacement parts, or to purchase the full Gilson Air Meter Kit, visit us at www.certifiedmtp.com. We are your partners in material testing. Subscribe and like this video to stay up to date with the latest ASTM standards and equipment reviews. Thanks for watching, and we'll see you on the next job site.